Okay, so we're having lots of technical issues. Next video, we're going to do the same thing with cubing and square roots. So cubing function is any function that's x cubed. That is one that you studied a great deal last year. So a lot of these you already know. I can sub anybody in. So the domain is negative infinity to infinity. The range, negative infinity to infinity. The root, the 0, the x-intercept is x equals 0. The y-intercept is 0, 0. You can look at it and tell me it's increasing everywhere, negative infinity to infinity, which means it's decreasing nowhere. It doesn't have any max or mins. And then our circle checklist. It's a continuous function. I can draw it without picking up the pencil. It is an odd function. If I sub in a negative x, I get exactly the opposite. It is neither bounded above or bounded below. And now I'm going to change colors and we're going to talk about the end pieces here. If I can make it all fit on the screen, that would be helpful. So talking about this side, when we talk about this side's end behavior, it's going down. We might say that it falls to the left, but it's down, and every time we're going to have this part, the limit as x approaches negative infinity of our function. And where did it go? It went down and to the left. It's going off and down to negative infinity. Again, pause this if you need to, because I'm going to erase it and fill in the other side. So the other side of the function is over here in red, or sorry, orange. It is going up. So we're talking about the limit as x approaches positive infinity of every function in this set of notes is f of x. And where is it going? It's going up and to the right, so it's headed to positive infinity. Okay, square root function. You also started this in Algebra 1, but you didn't, in Algebra 2 last year, but you didn't talk about it as much. The domain includes 0 and goes to infinity. So I've got a bracket there. The range is the same thing. I'm not sure why mine is blue on the screen. Y'all can read it. 0 to infinity. The roots, x equals 0. We're going to get to some in a minute that these have different answers. The y-intercept is still 0, 0. This is increasing from 0 to infinity. It doesn't have any decreasing intervals. It does have an absolute min at 0, 0. And I got to slide mine up so I can write. It is a continuous function. I can draw it without picking up my pen. It is neither even nor odd. It is not bounded above. It is bounded below. It doesn't go below the x-axis. So limits in behavior. I hope we're starting to see this now. I'm going to do it in different colors. We're talking about this one right here. It's headed towards 0. So we would say that this limit as x approaches negative infinity of f of x, it's not really going off to negative infinity. It just goes to that 0. I can't go to negative infinity on the x-axis on this one. So the limit here does not exist. And I will abbreviate it like that all the time. I'm not writing that out. And then I'm going to erase this so I can do the other side. And I'm going to do it in orange. So on the right-hand side, this graph is going up. So we say that the limit as x approaches infinity of this function, notice this is the same thing I've written on every problem. Where is it going? Well, this one, if I look at it as going up and to the right, it's going to infinity.